All right, so we're going to continue looking at special quadrilaterals in today's lesson. Lesson 4 is about rhombuses. So let's talk about the properties of rhombuses. One is all of the properties for parallelograms apply to rhombuses, and here's some significant differences or additions to a rhombus, and that is all sides of a rhombus are congruent. So that means this side, this side, this side, and this side. All four sides of the rhombus are congruent. They have the same measure. We also, a rhombus also have diagonals that bisect angles. So there's a diagonal, and this diagonal will bisect this angle, which means this angle and this angle are congruent, and this angle and this angle are congruent. Those angles are congruent. And we have another set of diagonals, or not another set, but another diagonal. And that means that these angles are congruent, and these angles are congruent. So diagonals of a rhombus will bisect angles, which means it will divide the angle into two congruent parts. And finally, a rhombus, the diagonals are going to be perpendicular. And what that means is that the intersection of the two diagonals will form four right angles. So the two diagonals are perpendicular. The angles will bisect angles, or the diagonals will bisect angles, and all sides of the rhombus is going to be, they're going to be congruent. Okay, so let's see. So now let's take a look at an example. Let's take a look at a couple of examples. So here we have a rhombus, for example 1, and if the measure of angle RST is 67 degrees, then RST, that means this angle is 67 degrees. Since this is a rhombus, then I know that this angle is congruent to this angle, which means they have the same measure. And what we are looking for is we ultimately want the angle measure for RSW. So what I want is this measure here. Okay, so we want this angle measure. So how do we find the measure of angle RSW? That will be 1/2 the measure of the angle at S, which is 67. And so the measure of angle RSW equals, I believe, 33.5. 1/2 of 67 is 33.5, and that's an angle measure, so that would be in degrees. Okay, so let's look at our next example. We have another rhombus, and the measure of SVT. We want to find this measure, SVT, if the measure of STV is 135. So what do we know? The angle STV, this big angle right here, is 135 degrees, okay? So what we want is, we want this angle measure here that I've highlighted in pink. So since the angle here at T is 135, then half of that would be this measure. And so half of 137, let's see, I'm sorry, not half of 137, half of 135 is going to be 67.5. So 1/2 of 135 will be 67.5. So this measure here is going to be 67.5 degrees. Well, I know this angle. If we also remember that this is a rhombus, then that means that the two diagonals intersect to form right angles because the two diagonals are perpendicular. So we know that this angle measure right here is 90. So if this is 90 and this is 67.5, we've got enough information to find the measure of this angle here. And so let's see. So 180 in this triangle. So 180 is the total angle measures. 90 plus 67.5 will be, what is that? No, that's not right. Sorry. So that's a 5. This is 3. What is that? 23.5. So 20, not 23. Yeah, that's 23.5, isn't it? So 90 minus 67.5. Something doesn't look right. So let's see. That's going to be, oh, I'm adding. I don't know what I'm doing. I'm so sorry. I'm adding. So 90 plus 167 is going to be 157.5. And so I need to subtract 157.5 from 180. And I'm going to get 0.5. And that's 2, and that's a 2. So the measure of angle SVT is going to equal 22.5 degrees. So my kind of got off track there trying to subtract 67.5 from 90, and I should have been adding. Okay, now I will say another way we could have done that, another approach to this, and some of you may have already thought about that, we could have approached this differently. This is a rhombus. We are told that this angle measure here is 135. Since this angle is 135, this big angle will be 135. When you add those two together, you get 270. And if we know that the angle measures of a rhombus add up to be 360, we then can subtract 270 from the 360, and that leaves us with 90 degrees. And if I divide, since I just want this little angle here, I know all 4 of these will be congruent. So if I divide 90 by 4, I'm going to get 22.5. So there's a couple of different ways we could have found that angle measure. Okay, so then we'll go on to our next one. Okay, so what do we know? We know that the measure of angle SWT is 2x plus 8 degrees, and I want us to find x. So this is measured, since this is a rhombus, I know that this is a right angle, and I'm told that this angle measure is 2x plus 8. So I can take my 2x plus 8 and set it equal to 90 degrees. I really don't have to have the degree symbol on there. But I will subtract 8, and that gives me, what, 82, divide by 2, and I get 41. So x equals 41. So this is just finding the measure of x, or the value of x. Okay, so now let's go to our last example. And we see that we want to find the value of x if the measure of angle WRV, this angle here, is 5x plus 5, and the measure of WRS is 7x minus 19. Okay, since this is a rhombus, then I know that these two angles are congruent because this is a diagonal, and a diagonal will bisect this angle into two congruent parts. So what I can do is set 7x minus 19 equal to 5x plus 5, and I can solve this for x. So I will subtract 5 to get 2x, and I almost wrote a plus 19, sorry, but this is 2x minus 19 equals 5. 2x, I will add 19, and I get 24, and in this case, x will be 12. So there is working with rhombuses, or some people say the plural for rhombus is rhombi. But these are your characteristics and properties for rhombuses. You know that all sides are going to be congruent. These diagonals are going to bisect the angles. And when you bisect something, you're dividing it into two equal parts. And we know that the diagonals are going to be perpendicular. Okay? So, that is your lesson 4.